Geometry, Chapter T for Transformations. First section, Section 1, we're going to be studying isometries. What is an isometric transformation? So it's important to know that an isometric transformation and rigid motion, those are the same thing. Those are synonyms. And there's another synonym for this. I'll just tell you what it is right now. It's congruent. Knowing that an isometry means congruent, we could probably finish the sentence pretty easily. An isometry transformation, rigid motion, is a transformation that preserves the distance and angles between the preimage and image. Now we're going to have to discuss what a preimage is and what an image is. But just know that if two figures are congruent, we could say there was an isometric transformation that got one figure to the other, or rigid motion that got one figure to the other. All right, isometric transformations, rotations, translations, and reflections. Oh my. So let me give you just a brief synopsis of what a preimage and an image is. Let's say that this figure, CD EFB, trying to just trace this. There we go. Put these on here like so. If I take this image and I rotate it, and it becomes this, I misspoke. If I take this pre-image and I rotate it so that it matches up with this other figure, the image, that's what an isometric transformation is. We just rotated this figure, so this is a rotation. Depending on where your point of rotation is, it probably would have been maybe someplace in this location. Once again, this is the pre-image, and this is the image. Oftentimes, we will call the pre-image with capital printed letters, and we'll call the image the same capital printed letter, but with a little tick mark on the side of it, prime mark. It just means new. Prime just means new. This next one, if we were to take this pre-image and we were to take it into slide, I'm having a horrible time getting this to draw my figures that I wanted to draw. If I take this pre-image and I slide it over, I would get this image. That is a translation. Now that sliding can be vertical or horizontal, or diagonal, or a combination of those. Once again, this is the pre-image, and this is the image. This next one, imagine that there is a mirror here, and this is a mirror image to get from over here to over here. It's called a reflection. This line of symmetry, which we'll talk about a lot more in the future, it acts as the perpendicular bisector of each segment, and each segment that I'm referring to has endpoints that point on the pre-image and a point on the image. So it's 90 degrees and it cuts that segment in half. This is known as a reflection. Right now, let's not get stuck on the details. Right now, all we want to know is what an isometry is, what appears to be a rotation, a translation, and a reflection. All the details that I'm putting in here at this point are not important. A non-isometric transformation, a non-rigid motion. This does not preserve the distance and angles between the preimage and image. Once again, preimage is before and the image is after. So what type of transformations are non-isometric? There are two, dilations and stretches. A dilation which produces similar figures. If you remember, similar figures has corresponding congruent angles. So angle C and angle C prime have the same measure. Angle D and D prime have the same measure. Angle B and angle B prime have the same figure. But if figures are similar, that gives them the freedom that one of the figures, if you multiply it by a scale factor, you get the other figure. So for example, CB is this length and C prime B prime appears to be much larger. So we would say that this has the same scale factor in 2 dimensions. Those dimensions would be vertical and horizontal. The next non-isometric transformation is a stretch. Now if we look at this figure here, I'm going to put it right, I'm going to put E right on top of E prime. Notice how F prime and G prime are the same distance that F and G were. What's happened is this figure has gotten stretched to the right. It got translated down and then stretched to the right. So a stretch has a different scale factor in 2 directions. For this particular preimage and image, the scale factor vertically might be 1, hasn't changed at all, and the scale factor horizontally might be 2, might be doubled. This one down here is also a stretch. If the dimensions are changed uniformly in both directions, it's a dilation. If they're changed non-uniformly, it's a stretch. All right, number 1, example. Circle which of the following are isometric transformations. It can be more than one answer. Isometric means that the image and the preimage are congruent to each other. Determine which transformation took place by writing reflection, translation, rotation, dilation, stretch, or other under each image. Now, technically speaking, this is the preimage. Certainly, there's been a translation in each case in order to get this to go here, or here, or here. We're just going to choose one transformation right now, and translation is not going to be one that we're going to choose because they've all been translated to some degree. So from here to here, is this an isometry, first of all? Are those the same size and same shape? No, not an isometry. Is this an isometry? Nope. Is this one same size and same shape? Yep, this one right here is an isometry. It's the only one. What's the transformation from here to here? Well, it looks like this figure was uniformly changed its size to make it smaller. That's a dilation. From the pre-image to image B, it looks like the vertical distance is the same. But it looks like it's been stretched horizontally, so that's a stretch. Comparing this pre-image to this image, it looks like the figure has been rotated. So we'll call this a rotation. You could say rotate, rotated. You could say stretch, stretching. You could say dilation, dilate. Part of speech doesn't matter. Same directions for number 2. It appears to me that this figure and this figure are both isometric with the pre-image. And it looks like this one has been distorted. This one would be a rotation. This one here would be a reflection. And this one here would be a stretch. Horizontally, it's the same length, it appears, but vertically, it's gotten much smaller. Number 3. Now we're getting a little more complicated. Determine the coordinates of the image, plot the image, and determine if it's an isometric transformation. Now, there's a lot of explaining I need to do here because I have not gotten into a lot of these details. The pre-image has the points A, -1, 1. You can see that clearly in the picture. B is 0, 4. We can see that in the picture. C is 4, 1. We can see that in the picture. Here is the rule that we're supposed to follow, the coordinate rule for this transformation. We're supposed to take whatever the x value was and put that in the position of where the y value would have been. We're supposed to take the original y value, put it where the x value is, and change its sign. So what that means is, for point A, we're supposed to interchange x and y. So that would be 1 here and -1 here. And we're supposed to change the sign of what's in the first spot. So instead of this being -1, 1, it's going to be -1, -1. B, supposed to interchange these and then change the sign of this number. That number being the new number that goes there. So if I interchange these, I'm going to get 4 and 0. If I change the sign of the first one, I'm going to get negative. Same transformation rule here. I interchange these. That's going to be 1 and 4, and I change the sign of the first one. So it's -1, 4. Now, what kind of transformation is this? I don't have any idea. Is this an isometry? I don't know. Let's graph it and see. So A prime is -1, 1. B prime is -4, 0. C prime is -1, 4. Connect those. Now, do those triangles appear to be the same? Obviously, they're the same shape. Is it the same size as the original? Sure looks like it. Now, how could we get this shape, the pre-image, ABC, to become A prime, B prime, C prime? It looks to me that we had a point of rotation here at the origin, and we rotated this, I don't know, maybe 90 degrees. So I would say this is a rotation. We're going to get deeper into looking at figures and trying to figure out what type of transformations they are. Right now we're just doing visual things. Hopefully you can see what's up. All right, we got one more problem, then we'll be finished. Number 4, same kind of directions. Pre-image is 0, 0. Our coordinate rule is leave x and y where they're supposed to be, but double the y value and make it negative. So x value, it doesn't change in each of these. So I'm just going to write those down. The y values, I'm getting these x values from the pre-image. The y values, we multiply it by -2. 0 times -2 is 0. 3 times -2 is -6. 0 times -2 is 0. Plot these points. 0, 0 is the same place the A prime is. B is 1 to the right. Let me move this. I'm sorry. Yeah, B prime is 1 to the right and 6 down. 1, 2, 3, 4, 5, 6. C prime is to the right 5. 1, 2, 3, 4, 5. And we don't go up or down. So first of all, is this shape same size as the preimage? Definitely not. It's not an isometry. If it's not an isometry, your choices are stretch or dilation. Dilation would preserve all the angles and lengths of sides. This doesn't appear to do that. This is a stretch, and it's no stretch to say it's a stretch. Write that down. Obviously, horizontally, it hasn't changed at all, but vertically, it is much taller than it was originally. Please do the homework as outlined by the website.